All right, so I had a request from a student in 5th period to do a few more examples of predicting products so you feel more comfortable with taking that second quiz. It's a sticky one. It's hard to do. You have to pay attention to charges and you have to pay attention to types of reactions and so on and so forth. So I'm going to go through these and message down below if you have any questions. So for this first one here, in order to predict what I'm going to make, I have to decide what type of reaction it is first. I've got an individual element here, aluminum, and I've got an individual element here as well, which is going to be chlorine gas. So I've got an A plus B situation going on. Hopefully in your notes you saw that an A plus B is a synthesis reaction, and you end up making something with aluminum and chlorine. Now, notice I did not carry that subscript 2 over because I've got to check my charges. Aluminum has a +3, chlorine has a -1, so this turns into AlCl3. Then I got to go back and balance. In order to go back and balance, there's nothing I can multiply by 2 to make 3, but I can say 3 times 2 makes 6, and 2 times 3 makes 6 chlorines, and that means just throw a 2 out front here. So there is an example of a synthesis. Next one here, I've got an AX plus a BY. And hopefully you saw that when I have an AX plus BY, 2 compounds, I've got a double replacement reaction, and I will make an AY in a BX. So I'm going to have the Fe go with the OH, and I'm going to have the K go with the Cl. And notice here, again, I did not carry over that subscript because I got to check my charges. I'm going to do the KCl first because it's easier. Looking at my periodic table, potassium has a +1, chlorine has a -1, so that cancels each other out. Now, the trick with this one is I've got to figure out what charge this iron had. So I got to work backwards here. Chlorine has a -1, and there's 2 of them. So that means to balance that out, that iron must have had a +2. So this iron has to have a +2. Looking at my polyatomic table, I will find that hydroxide has a -1. Flip the charges, make them subscripts. Here's my formula, FeOH2. And then I go back and balance. I need 2 Cls, and then I need 2 Ks. And so there's a good example of a double replacement reaction. The next one here, and when the people who have been taking that quiz have been doing this, few people are not recognizing combustion reactions. Combustion reactions are actually the easiest to predict the products. Whenever you've got a hydrocarbon, hydrogen bonded with a carbon, organic compound, burning in oxygen, your products are always going to be CO2 plus H2O, carbon dioxide and water. That's always what it is. Don't have to check charges. You don't have to do anything of the sort. You do have to balance, however. I got a 2 for the C here. I got a 2 for the H here. For my oxygens, I have 4. For the oxygens here, I've got 2. 2 plus 4 is 6, so I need a 3 out front here. And here's another double replacement one. I've got an AX and a BY. It's going to make an AY plus a BX. And I'm going to have aluminum go with the nitrate. Notice that 2 does not come over. This 3 does because it's part of the polyatomic, but this 2 does not come over. And then I've got a PB, lead, plus an SO4. Again, notice this 3 did not come over, and that's because we need to check our charges. this 4 did come over because it's part of the polyatomic. So checking our charges here. Aluminum has a +3, nitrate has a -1. So I have 3 nitrates to every 1 aluminum. And then looking at my polyatomic table, SO4 has a -2. Lead's a tricky one. It's not a transition, but it has multiple transition states. So I'm going to go back over here, look at my polyatomic table, realize that nitrate is a -1, and there's 2 of them. So this is going to total -2. So lead has to be a +2. And so PbSO4, they balance each other out. Last step, go back and balance. I need 2 aluminums, and I have 6 nitrates, so I need a 3 here like that. And then I need 3 leads, which will balance out the 3 sulfates over here. Here's the last example I want to do for you. Single replacement. Oops. So I know it's single replacement because I got an element mixed with a compound. A plus Bx will make a B plus an AX. So I'm going to end up having magnesium by itself plus a barium and an iodine. Again, notice that 2 does not come over because I got to check my charges. Here's a Ba with +2, iodine with -1. Flip the charges, make them subscripts. 2 goes down there. And then I think I'm balanced. 1 Ba, 1 Ba, 1 magnesium, 1 magnesium, 2 iodines, 2 iodines. Now, spoiler alert, this reaction actually wouldn't ever happen because we haven't learned this yet, and it's a kind of a year 2 thing. But barium is not as reactive as magnesium and is not strong enough to kick the magnesium off the iodine. So really the true answer on this one is no reaction. But for all intents and purposes, if it was to react, these would be the products. Again, this is just a few simple problems for you to practice those predicting products. If you have any questions, message me below. And thank you for listening.